Alright, so welcome to a video for section 1.9 on absolute value equations and inequalities for Math 1. And this is a handout that I gave you on Wednesday. It was a blue piece of paper. This is the front, and this is what the back looked like. It is a foldable, so when we're done filling it out, we're going to fold it along this line right here, and it'll fold along the middle here. It'll cross through some of the boxes, but that's okay. So if you need to, pause the video and go find that. If you lost it or were absent on the day that I passed it out, which was Wednesday, then you are going to need to print it if possible, and you can find that in the Math 1 Documents folder. Alright, so let's get started. So the first thing I want to do is remind you guys what an absolute value is. So what does the absolute value of a number really mean? Okay, well, recall if we have the absolute value of a number like -2, then that is +2. So it takes a negative number and it makes it positive. But what if you have a positive number? Then it stays positive. So regardless of what is inside it, it is always going to give you a positive version of that number. It doesn't switch signs, it makes it positive. But why does it do that? What does an absolute value of a number really mean? Well, it has to do with a number line. So if we draw a number line, and here's 0, we have our positives, we have our negatives, and so -2 is right here. I didn't do a very good job drawing my number line, but here's -2. The absolute value of -2 really means how far is -2 away from 0. Okay, so we're going to write this down. It's the distance from 0 on a number line. Okay, that's really what an absolute value means. So when you take a -2 and you're finding its distance from 0, it's 2. And when you're looking at +2 and you're seeing what is its distance from 0, it is also 2. Distance is always positive. Okay, so let's use this idea to solve the following. We have the absolute value of x is equal to 5. So we want to know what number can I plug in there for x that would make this true. So in other words, what number has a distance from 0 on the number line that is a distance of 5? Well, your first reaction might be, well, doesn't 5 have a distance from 0 of 5? And you would be right. 1, 2, 3, 4, 5. So 5 is an answer. But is there another number that also has a distance from 0 of 5? And the answer to that is yes, -5. If we go on the other side, -5 also has a distance from 0 of 5. So we have two answers. Okay, let's take this up a notch. What if we're looking at number 2? X, some number, plus 4, the absolute value of that is equal to 5. Well, we can think of it as when we add 4 to a number, the absolute value of it must be 5, or the distance from 0 must be 5. The first answer you might think of is 1, because 1 plus 4 is 5, right? The absolute value of 1 plus 4 would be the absolute value of 5, which is 5. Now, because we're dealing with an absolute value, we are going to need something else that could possibly make this into a -5. because if I have the absolute value of -5, that gives us 5 as well. So what value of x would make that x plus 4 equal to a -5? The answer is -9. Because if I take -9 plus 4, that's going to give me -5. The absolute value of -5 will give me 5, so that works as well. Okay? The third one is starting to get a little trickier. 3x minus 1 in an absolute value equals 6. At this point, you may realize there is a pattern here. We're looking at the inside here, in this case 3x minus 1, and we're asking ourselves what would make that 6? And what would make that -6? So let's set up two equations. For the first one, 3x minus 1 is equal to 6. We can solve this to figure out what value of x would make this 6. So add 1, you get 3x is equal to 7. Divide both sides by 3. It's not a pretty number, but it's fine. X equals 7/3. And we can check that. The absolute value of 3 times 7/3 minus 1 should equal 6. So let's see if it does. Here, the 3's cancel, and I just get 7 minus 1. 7 minus 1 is 6, so the absolute value of 6 is 6. So it works. But it's not the only answer, because we know that that inside can also equal -6. So if we add 1, we're going to get 3x is equal to -5. Divide by 3, divide by 3. And then the 3's cancel. And we get x equals -5/3. So we can check that answer. Okay, so I'm going to plug in -5/3 and see if it works. Okay, so 3 times -5/3. The 3's again will cancel, and I have -5 minus 1, which gives us -6. And the absolute value of -6 will give us 6. Alright, so you're not going to do anything in 4 and 5 right now. We're going to come back to that. You're going to go on to the other side, and we're going to go on to the left side. So this is a flow diagram showing you sort of the steps that you need to follow to solve absolute value equations. Okay, so solving absolute value equations. So with an equal sign. So the first thing you want to do is, so first you want to get the absolute value alone. And it should look something like this. The absolute value of ax plus b, so a and b will be filled with some numbers, equals c. So c is just some number on the other side. So if there's anything multiplying by the absolute value, don't distribute it. You cannot distribute with an absolute value. You would want to divide both sides by that. If there's anything adding or subtracting to the absolute value, you want to move that over, just like you would in a regular old equation. But think of it like you're undoing what's happening to the absolute value. Okay, so the next thing that we need to look at is the c value. So this c value is important. It must be positive. Why do you think it must be positive? Well, remember that over on the other side, we're taking the absolute value of some stuff. And absolute value is always positive. So this right here is always a positive number. So what we need to do is check to see if c isn't positive, because if it's not, we have a special case. So we ask the question, is C negative? And if the answer to that is yes, so for example, let's say you have something like this. The absolute value of 2x plus 3 equals negative 5. Okay? This is your C, negative 5. An absolute value is always positive. It cannot and will never equal negative 5. So if you see an absolute value equal to a negative, your answer is no solution. And you don't do anything else. You just write no solution and you're done. But that's only if you have a negative here, and only if your absolute value is all alone. Okay, so let's say it's not negative. Let's say the answer to that is no. Great. In that case, then we can solve it. So the way that we're going to solve it is like we solved number 3. We took what was inside 3x minus 1, inside of the absolute value, and we set it equal to two things. We set it equal to the 6, which is our C, and a negative version of the 6. And then we solved two equations. So that is what we're going to do. Okay, you're going to set up two equations. Okay, your first equation is the absolute value of, we don't have to write the absolute value anymore. We write what's inside the absolute value, which is ax plus b is equal to c. And then ax plus b is equal to negative c. Okay, so you have the stuff that's inside of the absolute value. Notice I did not write any absolute value signs anymore. It's just the inside. And then the c, and then a negative version of the c. It's really important that you solve two equations, not just one. All right, so then you solve each one. Okay, now this handout I made for my Algebra 2 class. So there's actually an extra case that we need to, or an extra step that we need to do, but for your guys, we're going to leave that blank. I don't think you're going to see this step. Okay, so next what we're going to do is we're going to practice some problems in your book. So if you can get your book. Okay, so we are on page 81 in your book. At the top of the page, we're looking at practice problem number 1. So it says the absolute value of n plus 3 is equal to 7. So if we look at our steps, the very first thing is to get the absolute value alone. Don't rewrite the equations first. You have to check this. So get the absolute value alone. Okay, so the absolute value is the absolute value of n here. It's not alone. We have a plus 3 to it. So just like we would do what's happening to x, we can do what's happening to the absolute value. It's being added, we're adding 3 to it. So we want to undo that by subtracting 3 from both sides. Okay, so we get the absolute value of n is equal to 4. Now that we have the absolute value all alone, the other part of the other step that we need to do is check to see that what about the value of c. Is c negative? No, it's positive 4. Okay, so it's a no. So now we're going to go to the part where we set up two equations. We take the inside of the absolute value is equal to the positive number outside, and the inside is equal to the negative version of the outside. And then we solve both of those. Well, the inside of our absolute value is really easy. It's just n. Okay, so we're going to write two equations. And so sometimes I like to write two arrows to remind myself there are two equations. So we have n equals 4, and n equals -4. And these are so simple we don't have to do anything else to solve them. All right, let's look at the second one. The second one says the negative 3, this is -3 times the absolute value of m. Remember, you cannot multiply these two things. You're not allowed to distribute, you're not allowed to multiply in. Distribution will work sometimes, but not all the time. So I'm just going to tell you, don't distribute, okay? So at first, if you're not careful, you may see that there's a negative over here and think, oh, no solution. But that's not actually the case because you didn't get the absolute value alone first, right? Follow the steps. Get the absolute value alone first, then decide if C is negative. So if we have to get the absolute value alone first, we have to get rid of this -3. Since it's multiplying, we are going to divide by -3. You might be tempted to add, but it's not subtracting. It's a -3 multiplying times m. So if we divide it, it'll cancel. We get the absolute value of m is equal to +3, because a negative divided by a negative will give us a positive number. So now it's not a case of no solution. We write our two equations. We get m is equal to 3, m is equal to -3. Done. Okay, go to page 82 and find problems 3 and 4. Okay, here you actually do get an absolute value all by itself to begin with. So now I'm checking to see if this number over here is negative, which it's not. So I can go ahead and write in my two equations. What do you think those equations are going to be? It's going to be r minus 8 is equal to +5 and r minus 8 is equal to -5. All right, you're going to make the 5 and the -5, and then the r minus 8 is here. Notice there's no more absolute value signs. They're gone. When you rewrite it, they disappear. So we add 8, we get the r is 13. And we add 8, we get the r is 3. If you plug them both in, they should both work. Okay, we're going to skip 4, but it's the same idea, it's just the sides are flipped. And at the bottom of page 82, let's just do one more to kind of tie it all together. Let's do number 5. So first question, is the absolute value alone? The absolute value is right here. Is it alone on the side of the equation? No, it's being multiplied by a -2. So we have to get it alone. So we're going to divide by a -2 to both sides. Cancel, cancel. Absolute value of 7d is equal to -7. Now if you're not careful at this point, you may just start writing your two equations and think, oh, 7d is equal to -7, and then 7d is going to be equal to +7, and you're going to get 1 and -1. You're going to be happy, but it doesn't work because you didn't pay attention to the fact that this is a negative. Maybe. I don't know. Maybe you saw that. But it's a common thing to just not pay attention to that. So you have to stop and ask yourself, do I have an absolute value equal to a negative? I do? Okay. Then I have no solution. So this is wrong. This is wrong. Your answer is no solution. Okay, so this is the end of the first video. I'm going to do the inequality stuff in the second video.